really happy to see Gwen give a talk about QuackDB and how to make, a DuckDB. I'm sorry, it's DuckDB. So take it away, Gwen. Let's give her a hand.
Thanks, everybody. What a quack is this, Paul, right? All right, so thanks, everybody, for coming. My name is Gwen Prawiroatmodjo, and I'm going to talk to you about how to bootstrap a data warehouse with DuckDB. And I'm here together with my colleagues, Alex Monahan and Elena Felder. You'll recognize them by their beautiful duck shirts. We're also here with the duck tub. It's a duck-shaped tub with duckies in it. It's at the door. If you would like to grab one, feel free. And we gave a tutorial on Tuesday, if you want to check that out. The link is up on the slide, where we taught you all the SQL that you need to know as a Pythonista. So first of all, what is a data warehouse? So a data warehouse is a place used to collect, store, and collaborate on your data. So it's a database system with a query engine that you can use to collect all your data from all your different data sources with the purpose of collaborating on it with your colleagues, sharing it, and it can be a source for data analysis or other downstream data processes or visualization. Now, you might wonder, why would I need a data warehouse? I don't have big data. Well, our CEO, Jordan Tigani, wrote this blog post, "Big data is dead." What he means by that is, of course, it's not dead, but 10 years ago, it was what everybody believed was the future, all right? So Jordan, at the time, was at Google. He was one of the founding engineers of Google BigQuery, which is big data product. And he evangelized this message: by the current year, plus some epsilon, there will be an unfathomably large amount of data generated. Spooky, spooky, spooky. Your infrastructure will fall apart. Buy your product, we will save you. So that was kind of the story. But what he found in that last decade working in big data is actually the vast majority of enterprises don't have big data. They have data warehouses maybe smaller than a terabyte. So you see this graphic, it's kind of like a power law or Pareto distribution. So, and even worse, the customers that did have these giant data sizes almost never queried that data altogether. Maybe once a year and doing like a big aggregate report or something like that. But most of the time, like 99th percentile below, it's maybe like 10 gigabytes, which is not big data. So what about big data and science? So we saw the keynote this morning on the Atlas experiment at CERN. Okay, that's big data. That's exabytes of disk storage. It's a little bit special. All this data stored on tape. It's not something you'd run in like an enterprise cloud database. But this is this is some solid big data, and I'm not going to say that is absolutely alive. However, if we look at other, big data sets. So for example, if we look at Cornell's ornithology department, eBird. So for the birders out there, you might be familiar with this website. It's a citizen science project. If you're a birder, you can go there, you can submit your checklists, and it has data from all over the world of bird observations up until like 50 years ago. And that whole data set, you can actually download it. It's about 40 gigabytes if it's compressed. If you decompress it, it takes about half a terabyte on your computer. So it's still something I can run on my computer. So I wouldn't really call that big data. And it's still a lot of data. And then Hugging Face, so is one of the biggest websites for machine learning models and data sets out there. Actually, over 99% of those data sets are below 5 gigabytes, which is, again, not big data. So here's a plot that I took earlier this week of just the data sets you can find on their website. I took the first 42 pages on their data set browser. And as you can see, the vast majority are at least under a billion rows. So your question might be, okay, then why do I need a data warehouse or a database? Well, at MotherDuck, we actually believe that databases are extremely valuable for small to medium data workloads. First of all, you can go much faster than pandas. You can handle larger than memory data. So I mentioned the eBird database, right? The 500 gigabytes of bird data. Try and load that into pandas data frame. That's not super fun. There are a lot of other tools out there, of course, to be able to do that. But databases can do that really, really well. And they've been built specifically for that purpose. then SQL is a beautiful language. I actually learned SQL before I learned Python. It's declarative. You just say what is the data you need, and the query engine figures out for you what to do and how to do it and how to optimize it. Oh, folks in the back, feel free to take a seat. There's some more space over there. One other really great thing about using a database is you can package all your tables into one file. So for DuckDB, which I'll talk about shortly, it's just so much easier to put everything together instead of like CSV hell, you know, where you have like table 1, table 2 final, table 2 final, really final, December 2023. Yeah, you know, you got where I'm coming from. And another advantage of using SQL, using a database that is SQL, that implements SQL, you can manage data pipelines with modern data and engineering tools. I'll give some examples later, like dbt, for example, which is very convenient. So now back to DuckDB. So DuckDB is a lightweight, in-process SQL analytics engine that is taking the data world by storm. It's been developed at the CWI, the Center for Mathematics and Computer Science in Amsterdam. It's the same place where Guido van Rossum way back when developed Python. It's developed in a group of Pieter Bonks by Hannes Mulissen and Mark Raasveld, who have started a company called DuckDB Labs at MotherDuck that we collaborate with. And it's actually quite awesome. It's really taking off. It's MIT licensed. There are clients in over 15 languages. So I listed some on the left here: Python, WASM, R. There's a CLI client. It works with Rust, Java, JavaScript. There's about 1 million downloads a week just on PyPI. And it's just, you know, I took this info from an older slide, and it used to be 1 million downloads a month, like a few weeks ago, and has 1 million downloads a week, so it's really taking off. It supports a lot of different data formats, so it's very similar to Pandas in the sense you can very easily load data, and it's very fast, and it has great interoperability with the tools in Python ecosystem like Arrow, Pandas, NumPy, Polars. It can read SQLite files. And it works really great with cloud systems. So, for example, if you have a bucket with data on AWS, for example, or some other blob storage, you can read it with DuckDB. And check out duckdbstats.com on the bottom left. If you are watching this talk a few weeks from now, the number that I'm quoting here will probably have changed. There's a live version of the plot on the top right that my colleague Mehdi put together, and it's really cool, actually, so check that out. And it runs on DuckDB. Just a little bit more about databases for those of you who are familiar with like Postgres or MySQL or SQL Server. So the typical architecture of a database is one of a client and a server. So I have my application that runs a client, and it connects over the network to some server, like a Postgres server, like that little elephant guy on the right. It's a monolithic application. It hosts the data in a query engine, which is then separated from your application. And the network is slow and untrusted. Actually, that network connection between Postgres and your application can be slower than just downloading a CSV. So it's very old technology, very stable. Of course, there's some really good use cases for it. But you know, for the modern data analytics world, it might not be exactly what you need. Like you connect to it with a host and a port and a username. It's all a lot of overhead. So the beautiful thing about these in-process database architectures like SQLite or DuckDB is that everything lives in the same process. So there's no trust boundaries to traverse. It's super high bandwidth because there's no internet pipe or anything to traverse. And it's serverless. So serverless is a bit of a technical term, but what that means is I don't think about my database as being a separate entity somewhere on the internet. I just connect to it with DuckDB. As you see in this example here below, you specify a file name, DuckDB, mydb.duckdb, and I'm off to the races and start querying SQL. So now what is MotherDuck? MotherDuck is a serverless DuckDB platform. We aim to enable low-cost, low-friction analytics that will scale to support more complex apps and data. And what that means is, when I say serverless, it works very, very similar to DuckDB. In fact, anywhere you can DuckDB, you can MotherDuck. That's one of our mantras. So if you connect to DuckDB in the CLI, for example, that's what that would look like. If I now want to connect to MotherDuck, all I have to do is I replace that string that goes to my persistent database on disk to MD : and then the name of my remote database. And what that does, so if you see in the picture here, if you got your application with your DuckDB, it creates or it allocates to you another DuckDB instance in the cloud that's going to talk to your DuckDB instance on your laptop. And since this is SciPy and a lot of physicists in the audience, I'm going to use lasers to explain this. So let's say your DuckDB on your local machine and your DuckDB on your cloud instance, they have laser eyes and they talk to each other with lasers over the network. But the beauty of it is you don't notice any of that. It's all abstracted away. So everything happens both local and remote. But you use that SQL, that declarative querying language. It automatically uses cache, and I already mentioned serverless. So that query is optimized. So I can tell you a little bit more just to demonstrate an example. Let's say, again, you have that duck with that bucket in cloud. Let's say it's on the AWS S3 storage. If you connect to that with DuckDB, which you can, you would run a query like this, like in the bottom. You select star from read Parquet. What that does is it looks at all the Parquet files. So I do star.parquet, which I think is already super cool that you can just do that. It scans all of the Parquet files in your bucket, and then this query just gets the top 100 rows. Right? So what that does is I make a request and I get the data back. Let's say I'm somewhere and I have like maybe 100 megabit per second internet connection. And then most of the data crunching, like the monch here in this picture, happens on your laptop, right? So DuckDB has some optimizations here, so it doesn't like download all of those Parquet files and then run the query. It does actually do some subset. So not all of it is sent over the wire, but there's still a pretty big chunk of data that goes over that not super fast internet connection. So enter MotherDuck. The nice thing about MotherDuck is it's all deployed in the cloud. So we can take advantage of this 100 gigabit per second speed that's going to be happening between friends' services in the cloud. So instead of that initial query, initial data transfer happening between your laptop and the cloud, now that's happening between your MotherDuck DuckDB instance and your S3 server. So now some of the monching, some of that data processing is happening in the cloud so that only those 100 rows that you requested are actually being sent over your slow internet connection. I've illustrated this again because we're all physicists, or a lot of us are physicists. The green laser is higher energy than the red laser. So you do the green laser for more data. The advantages here, you've got pretty fast ingestion of cloud-based data. A lot of that you can outsource, and this is all, again, it's all abstracted away. I don't have to think about this. There's a bunch of really smart computer scientists who figured out how to make this all very optimized. All you need to do is just say declaratively, this is the data I want, and it will show up. So to just go into this a little bit more, we've got this explain statement in DuckDB SQL. Explain is going to show you what the query plan looks like. So the query plan, so this is a very simple query, right? Select star from read Parquet. So I've got only and the limit, right? So I've got only 2 steps here. I've got read Parquet and limit, right? So this is on DuckDB. Then on MotherDuck, because we have that dual execution engine for those hybrid queries, there's now going to be these L's and R's in my explain statement. So some of the parts of the query are happening remotely, that's the R, and some of them are happening locally. So you can see here, the read Parquet, the limit, and the download are all happening remotely. And then the last download is happening locally. So just to give you an example, so my colleague Elena here, who lives in New York City with very fast internet connection, with all the stock trade and exchange, you need fast internet. And it's closer to the DuckDB server, of the MotherDuck service as well. So I've run this on DuckDB without, MotherDuck. It takes about 300 seconds, which is still pretty good, I would say, if you're doing like a select. Then on MotherDuck, it takes about 40 seconds. So pew, 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 lasers. It's all very fast. So we've got 10 minutes left. So if you want to learn more about this, our colleague Stephanie talked about this in this recent Quack and Code episode on dual execution, and there's also a paper about it in more detail. So now back to data warehouses. Now I have a really cool in-process database. How do I build a data warehouse out of it? Let's extract, load, and transform some data into it. DuckDB and MotherDuck have a pretty great ecosystem of tools. Here are all these different kind of ingestion, data science, business intelligence tools. All of them have at least one open source option in there that you can use. And I'm going to show you how to do that with DuckDB and only open source tools. So step one is you just build your data pipeline. You come up with some analysis and some data crunching. Then step two is you share it. So that's something you can do with the tools I'm going to be showing you. And then step three is collaborate. So that's the only step that we'll need MotherDuck for. But 1 and 2 can all happen just on your laptop with free tools. So I've created a cookie cutter for this. Here you see the commands you can use to install it and to run it. And I'll just show you a really quick demo what that looks like. So what tools are we using for this cookie cutter? So I used a data set called AvoNet, which has the morphological, ecological, and geographical data for all birds. What I'm going to do is I'm going to do some quick ELT on that to get all the birds that are ducks. Then I'm going to store that data in DuckDB and MotherDuck for the collaboration part, and then I'll make a quick data visualization with Plotly and JupyterBook, and then publish it on GitHub pages. So yeah, let's go to the demo. So let me see, here we go. So I've already created a virtual environment, but if you go to the cookie cutter page, it explains to you how to make a virtual environment and how to install all of the dependencies. So I'm just going to run this cookie cutter. Yes. Okay, then it's going to ask for your full name. Sure, I'm Ducky McDuckface, why not? My email address, my GitHub username. So this is all just so to link. So my project name, so I'm going to call it my Ducky Data Warehouse. And then just a quick project description. And there we go. And I can pick a license. So now my cookie cutter is cutting the cookie for me. So now it's created a folder, Ducky Data Warehouse. You can go in there. So here is the README, and it, which kind of just has the text that you put in your description. Then you go into your JupyterBook folder. There's the config, the table of contents. So I've got an example in here. So the way you would build this locally is you would run JupyterBook build dot in the book folder. And what that does, it's actually going to run all the notebooks in your example folder. So I've got a few notebooks. So I'm kind of using JupyterBook here, both as a data pipeline tool, so to execute my extract, load, and transform steps. But I'm also using it to generate a report. So the data is the report, basically. So as I'm running here, and I generate a summary at the end. So as you can see here, I've named all the IPython notebooks with 1, 2, 3, 4. That's kind of to enforce the order, because JupyterBook is going to run these notebooks in alphabetical order. All right. Now I can open this here in my local folder here. So as you can see, I'm just fully local. Got my little Ducky Data Warehouse. Got my index here. So yeah, so here's the iris data set. Wait a minute. That's not irises. Those are ducks. Oh yeah, of course. Thank you. Bigger, more ducks. So this is inspired by the classic iris machine learning data set. I've taken a few different duck species that are easy to distinguish. Took the measurements from the AvoNet data set. So tarsus length, that's like the length of the leg, then the beak length, and then the size is the beak width. So you can see Egyptian goose is actually a duck, even though it's called a goose. So learned something today. Then, yeah, more plots. So this is kind of my summary report that I made. It's just a markdown file. All the Jupyter cells are hidden. Then my colleague Till, who's leading the machine learning team at MotherDuck, made a little like a 101 machine learning model for us using this data set. And it looks like it's about 80% accuracy. So that's pretty good, given that I only have 5 or 6 data points per duck species. And then I've created a data share. So this is now shared on MotherDuck. And I can actually attach it. So if you want, you can try this out and you can attach it. So just to go into this Jupyter book a little more. So this is my Jupyter notebook I used as the first step. So this crunches all the data. It loads the raw data from the bird data set. It gets the ducks. It does the join. And then it gives me here, I do a little bit of data analysis here to make sure that I actually picked the right ducks. And then I save it to a database. So here I create a table called duck iris. So if I actually go back into my terminal here, and then into my example folder, I see that it actually created a DuckDB database called my data. So now all the data from my little pipeline has been stored into that DuckDB file, which is really nice because now I can leave these CSVs behind. This is now history. And now I can go into that notebook that my colleague Till put together. I connect to my database where my prep data is. And now I can do some more prepping here. You know, I get my target mapping. So I map the species onto a number. I create my machine learning table and I do some sampling. I'm not going to go through this in detail, but yeah, basically now I can create my model and do my predictions and see if based on these measurements of birds, I can predict what kind of duck is it. Then I did a little bit PCA analysis. So as you can see, I can just iterate on my data. I can modularize my data analysis into different files without having to drag those files, those CSV files with me. I can pre-process. All my steps are now in my database. So there's some PCA. So there's different components of the duck measurements. And then here, if I want to create a share on MotherDuck, so that's step 3. If I want to share it, now I can connect to MotherDuck, create a share from that. So first I create a database called my data from that DuckDB database. So this all uploads all my data into the cloud. And then I can create a share here. And now I can send this to my colleagues. They can attach it into their MotherDuck account. And then they can start playing around with my duck data. So yeah, so this is now all local. So how do I actually publish this? So the cookie cutter actually comes with a GitHub workflow. So when I take the cookie cutter and I push the code to a GitHub repository, it will actually run the Jupyter book build step in here. So it will pip install the requirements. It will run the Jupyter book build here. You can see that. And then it will upload the HTML artifacts to GitHub pages. So you can use this. It will automatically build everything when you push new code. Just make sure to enable the GitHub pages before you do that. And then here, so here's an example. If you go to the cookie cutter data warehouse, so it's on bit.ly link. Here is the link to the example that I just showed you. So it's all online. Just, yeah, everybody can try and do some duck characterization. Then, yeah, I just wanted to give a quick plug to my colleague Mehdi. He created this really cool data pipeline called PyPI DuckFlow. So that's this DuckDB stats page that I talked to you about earlier. So this shows you all the downloads from PyPI. And there is some GitHub workflow in here that periodically grabs the data from PyPI. So if you're interested in actually having a full data warehouse data pipeline here, he uses dbt to get all of that set up. So I've got about a minute left, so I'm going to just quickly wrap up here. So check it out. I wanted to give you a really quick sneak peek for Save the Date on Monday. Follow us on social media, on LinkedIn. Something small is coming soon. So we'll announce what that is on Monday. So thank you all so much for coming and for your attention. And my slides are published here. And join us on Slack if you want to continue the conversation. And I'll take your questions now.
Thank you, Gwen. Are there any questions? Here we go.
Thanks, that was really nice. I have a question, maybe it's about the dual execution architecture. Earlier in the talk, you said like Postgres is great, but it's on the other end of this internet connection, which may be slow. And then you said MotherDuck is great because it's on this other end of the internet connection, which may be slow. What is it that DuckDB and MotherDuck do that like kind of solves that problem? I don't think I fully understand that.
Yeah, thank you. That's a really great question. Let me see if I can go back here. Well, lasers, of course. So it's mainly, if we go back here, so it's mainly this query plan optimization, right? So if I work with Postgres and I run a query, all of that is going to be happening like on the server. It's not going to use the compute on your local machine. So what MotherDuck does, we actually use your compute power on your local machine in addition to the compute power in the cloud. So there's still that slow internet connection, but we're going to make sure that that as a bottleneck is minimized. So it just, let's say you have a really big query, a bunch of steps, it's going to calculate what is the minimum data that needs to be transferred to make this query happen. That gets planned to be transferred on the internet, and then the rest of the query will happen locally on your machine. So if you're like me and you've got like a MacBook or some powerful machine, you're not going to notice the difference whether it's running on my local machine or in the server. Like it's probably even faster than like a cloud compute instance. Sure, great question.
Other questions?
Is the remote instance configurable, and is there any benefits of changing configuration, like the size of where that remote instance is running, like how much memory you have or how much disk space and what you're actually reading? Is it auto-optimize?
That's a really great question. So right now we don't offer that option. If you're interested, I would recommend you to come talk to us after. My colleague Alex here is a forward deployed engineer. He works a lot with our customers to make sure that they have the compute they need. We intend to be, like I said, completely serverless, so it wouldn't be something you have to worry about. But definitely, if you have more questions about this, come talk to us.
All right, I didn't see anything on Slack either. Let me check one last time. Maybe I'll ask a question. How do I know if I need a data store? Like,
yeah.
At what point do I go and build one?
Yeah, if you feel like you're drowning in CSVs, there's too many CSVs to keep track of. If you have a data pipeline that has a lot of different steps, and you would like to be able to go back to any point in time, that can be really, really valuable to save all those intermediate tables in a database and not have to worry about, versioning files and stuff like that.
Cool. Let's thank Gwen one more time.
Oh, and there's some